We're live. Yo, welcome. Today I want to work on the Windows 95 screensaver I was working on yesterday. So if I go to work, what did I call this? I called it Stream Simulator. Okay, so what this project is on TikTok, people put in videos of people playing Minecraft or Subway Surfers or Family Guy clips or people like cutting up soap alongside whatever they're actually doing, and that keeps people's attentions. I am making programming content, which is boring as all hell. So what I want to do is put something on the side, maybe like right here, that's pleasant to look at, so that when I'm just sitting here touching numbers, changing variable names, there's something that's like at least like semi-interesting to look at on the side. So what we got yesterday is we got to a point where we could procedurally generate a maze. Hold on one sec. Forgot to set up some of my stream stuff. Here we go. Yeah, so where we got to was, I think if I just open this, we'll see it. Yeah, so we took this algorithm for maze generation, stuck it into Godot, and then added some like terrain pieces that we could stitch together and turn into a map. So that's looking okay. But if I put my camera inside the maze right now, which is where it will eventually go, oh, he's tiny. Let's just kind of move him around so that we can. How do I like find him? Here we go. A little up, a little right, and let's. Oh my gosh, where are you looking, man? Oh no, what have I done? Okay, we'll put the field of view to like 75, and let's have him look straight. 0, 0, 0. Why is he rotated like that? Oh, this is not 0. Okay, let's have him look down the hall. Okay. And if we like look here, it's very unpleasant. And I don't even know if you can like see anything. I think that this is with sunlight toggled on. What happens if I play Kinig? Okay, so that's useless. So I think first thing that I want to do is I want to get to the point where this looks like there's something here. And second, implement movement. First time chatter. Hey Josh, what's up? Fortnite Llama. We're learning. Okay, so let's pull up a reference. If I Google the Windows 95 screensaver, it knows what I want. We want this guy. Can I just like stick him over here somewhere? And let's pop open Blender and start trying to make my hallways look just a little bit like this. So I'm not really sure how textures in Blender will translate into textures in Godot. So that's part of the fun for today. Okay, so in Blender we have like each of our different tiles. So at a dead end, you come into this box. Oh, that's a dead end with this box straight through this one, etc. Four-way intersection is just a floor and ceiling. Fun. So I think I want to just try to make it look like this for now. Later, we'll do some post-processing to make it look like shit, like it was back in the day. But for now, I'm just going to slap on something that looks like anything. Just like somewhat presentable so that I have something to work with. Okay. So I think I click this button and I can see something that looks like how it's going to look like for real. I guess I need like a light or else I'm not going to be able to see anything. I like just put in an environment. I'll just like throw a sky in here. Oh, it's so hard to look at. How do I want to do this? Smoke this, just add a light. Light. Point. Sure, let's put it inside the box. That works for me. Okay, so the ceiling has like these gray bricks. The walls have red bricks. I think there's like a brick texture in Blender that I can just cheat and start with using. Okay, bricks on the floor and ceiling. I guess probably if I take like text the coordinates of where I am on the object, split them up into individual components, and then just like swap them around. Just like swap Y and X or Y and Z. That gives me on the back wall. And I guess I can just do this again, but swap it so that I get some on the front, on the side walls as well. Let's do this. I think if I add these together, does it give me something that will move in both directions? What does it do? What do I want to swap here? Just throw some shit around. Oh, adding's probably not at all what I want, actually. Bricks are going sideways. Wrong. So here I want, what's this default again? X, Y, Z. Default is to be on the ceiling, which means that it's moving along X and Y. So if I want it on this wall, I want it on Y and Z. So I guess I just like do this. And then they're sideways to flip them around. Okay. And if I then add these together, does it... I think that's what I want. Yeah, there we go. Bricks on each side. They're red in the photo, so make them a little red. I don't know. Pretty dark. I guess I just make them all kind of dark. Sure. And they're bigger, so I want them to be bigger. Sure. Good enough for now. I can always come back to this and fix it later. Let's just kind of see what this looks like if I put it in the game. I need another material for the floor and ceiling. I could try to get fancy with it and put more in here, but I don't want to. It's easier to just split it up. So we'll call this bricks. And we'll make a new material for the floor, and we'll call this get crazy floor. And assign this to that. And we need one for the ceiling as well. New chill ceiling. Ceiling also looks like bricks. Brick. And I'm not going to put too much effort into this, I guess, because I just want to see what it looks like if I import it into the game. And this is just like brown. I don't know. Like brownish. And we'll fix that later too. Okay. So now we just need to do the same material assignment for each of the different versions. So this is ceiling, and this is floor. Okay, this guy's good. This guy is not good. So this guy needs one for the ceiling, one for the floor. This should be on the ceiling. This should be on the floor. Okay, one more, I think. Two more. Riveting content, I know. Riveting. So this guy needs ceiling, floor. And this guy needs ceiling, floor. Okay. I think that's it. This guy looks good. This guy looks good. This guy looks good. Looks good. Looks good. I don't know if I export this, if it's gonna export the light as a tile. That would be annoying, but I guess we'll just do it and see what happens. So we export the meshes. Can I include... Ooh. I can do it by collection, so I guess I just put a new collection for, like, no export. Okay. And then I will export the collection I care about, so I'll click this, I guess, probably. Export. Glub. Include active collection. Export this. So now I think that this re-imports it. So if I look at the meshes that I have here, do they look reasonable? Which one is it? This guy? No. That sucks. I was kind of hoping that if I just threw these in here, that I would get them in Godot. So I guess that means that this, like, brick texture is not usable. Well, I guess maybe it's not filling in the object coordinates correctly here. Okay, let's open a new Blender instance, and we can see if we get what we exported back. So I have absolutely no idea what it exports here. I actually don't even know what's in these. Okay, so if I open this guy, go away. Yeah, it looks like crap. Okay, so that's good to know. Good to know. What does my exported shader look like? Nothing? Very cool. Gotta do some Googling, I guess. Blender GLB export brick. Maybe I just have to hand roll it. Bum 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 bum. Okay, meshes, blah blah blah. Image texture, normal map, emissive. Where does it tell me? Oh, here we go. Supported only certain types of animations. What about, like, materials? Why? I would assume that it would implement these, like, fancy textures in a way where they're exportable, but I guess not. Exported materials, where did that go? Baked ambient occlusion, normal map. Wait, I just saw it. Materials. Okay. Supports metal, rough PBR, and shadeless materials. It will construct a GLTF material based off the nodes it recognizes in the Blender material. When image textures are used by materials, GLTF requires that they're in PNG or JPEG format. To create shadeless unit materials, use background material type. Lame. I was kind of hoping that I could, like, procedurally generate the bricks and have them texture the walls without having to, like, UV unwrap and make, like, a seamless texture and stuff. How do I know? What other export types are there? Nothing great. Nothing great. GLTF noise textures. I wonder if I can, like, export map. Okay. They just want me to bake them into image textures prior to up. Lame. Lame. So I guess the other way to do this would be to implement the shader in Godot. Use that to generate bricks. But that seems like more work than just slapping an image texture on for now. Lame. Let's see if there's Godot procedural textures from Blender. Is there like some sort of like interop I can do? Bake image it, bake. Go to new tool. Doesn't support procedural textures. Alright. Fine, I'll do it the lame way. Seamless brick texture. Here, we'll just steal this from Pinterest. None of these peasant bricks. Mario, let's look. Mario bricks. Oh, no, I want like the old ass ones. Mario, Super Mario Bros. Bricks. Sure. Fuck it. Works for me. Now I guess if I was like actually doing this, I would need attribution. So I guess I just copy this link. Bricks. Do I need brick? Do I need to attribute this somewhere? No. This is just like the Mario bricks. I guess I'll copy the link just in case and write it down. Attribute all 16 pixels. Yeah, I'm sure I could just like make it by hand and it would be faster. But fusions text. Whatever. And this is just Mario bricks. And if this ever comes up again, I'll just delete them and make them myself. Nobody will ever care. That's the real answer. That's the real answer. Hey. So I guess here, screw this. I guess I have to text UV unwrap all these, which is a pain. But I think you can just like cheat and do this. UV editing. And if I just project from here, I'll just have the bricks perfectly line up on the left and right. I don't really care for now. And I'll just UV project from view, and then can I just like, oh, this is so imprecise. UV cube projection. Yeah, I guess we'll just do this. That's fine. That's fine. So now I have like UV coordinates here, and I need to make sure that the top, anything that aren't like the side faces do I need to take these out? No, because I'm doing this, I'm splitting the materials by wall, which means that I can just, these are just import probably the whole picture of the brick and call that a day. Let's see. Where was I? So here, screw the brick texture. Oh, let's look at the bricks and image texture. Throw that in here. Open up bricks. They're massive, so can I just like scale them down? If I do like vector math and I multiply my UV coordinate by a bunch, that should make everything smaller. I wonder if the GLTF will let me do that. We'll find out. Value. And this will just multiply by like 4. 4 times smaller, please. Okay. That's definitely not seamless. But we'll live with it for now. Let's just see what happens if I export this. Export. GLTF. And then in my other Blender window, oh my gosh, let me click these. Thank you. Delete everything and re-import them. Thank you. Impeccable masonry. That's right. This is quality work right here. Okay. That looked... Which one of these looked reasonable? Okay, so they're definitely not scaled. Oy, 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 which means that I have to do this with UV coordinates. I'll just shrink it, I guess. Grow it. Grow it. Oh, the texture might be seamless, but I just might be mapping it really poorly. In fact, that's definitely what I'm doing. If I look at these need to be scaled to match the height of the texture. Obviously. Obviously. Okay. Pull these guys down. Just really precisely. This is how you... There must be a better way to do this, but whatever. This can be 4 times in this direction. No, 3 times? 3 times, 3 times, 3 times. Okay, what does it look like now? Okay, too big. Can I... Scale. What's like a reasonable size? Like this? I think they're bigger in the... Oh, I'm gonna UV map all of these the same. That's gonna suck. How do I avoid that? Oh, I guess I just have to actually set these vertex positions and remember them. So this can be at 0.1, 0.1. Oh god, that's ugly. Where is this now? 0.1, 0.9. And these ones can be at 0.9, 0.9. And these ones can be at... What are these numbers? Oh, here. So this should be 0.1, 0.1, and this should be 0.1, 0.1. Oopsies, this should be 0.9. Okay. Nope. Oh, no. Oh, no. Do those look about the right size? Let's pull up the reference. They're actually too small. I don't care. I shouldn't be thinking about this much at all because I just want something. I can come back to this later. So if I export this, do I get anything sane when I re-import it? This guy. Oh my gosh. Delete, delete, delete. I don't want you. Import. Meshes. They're still massive. Oh, because I only have one that is correct. Why are my UV mappings not working? Do I still have these scaled in the texture? Oi, 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 oi. I do, and that's illegal. Okay. Alright. Alright. So let's go back to the UV editor, and we have to memorize these numbers, so let's make this like -1, and we'll make this 2, I don't know. And we'll make this 2, 2, and we'll make this -1, 2, and we'll make this, what is this, -1, 2, I think? No, -1, -1. Those are approximately sanely sized bricks. If I stack these two next to each other, do they like kind of line up? Yeah, sure. Closely enough. But I don't care. Okay. Export. And then in the other Blender window, we import again. And we ignore all of the broken ones and look at the straight on one. Yep. Good enough. Good enough. So now I just have to slowly and painfully apply these same UV unwrappings to the other guys. Very fun. Okay. Where's the opening? Why can't here? Okay. So what did I say this was? This was negative 1, 2. This was, oh my gosh, 2, 2. This was 2. Nope. This was 2, negative 1. See, this is why this project needs to be done at all. Because I'm just listing numbers. And that's really boring. Like, really boring. So, let's just try to rip through this. Oh my gosh. Oh my gosh. 2. This should be 2. This should be y, negative 1. This should be x2, y, negative 1. And this should be y, negative 1, x, negative 1. I'm sure there has to be a better way to do this. This is so boring. Boring, boring, boring. But what you gonna do? We'll do it again. 2, 2. Negative 1. 2. Negative 1, negative 1. And I think this is probably the same where they're rotated. This has to be at 2, 2. 2. This is negative 1, 2. This goes to x, negative 1. And this goes to x, negative 1. Negative 1. All right. Okay, 2 down, 3 more to go. 3 more to go. So this is, I guess I could start by doing like a project from view. Is that worth it? Probably not. Oh, wrong viewport, wrong viewport. Okay, so this goes here. This goes here, this goes here, this goes here. I need to rotate this like this and then start punching in the right values. 2, negative 1, 2, nope. Negative 1, 2, and negative 1, negative 1. Okay. 3 down. No, not 3 down. This one has to do the same thing. Oh my gosh. Oh goodness. This goes to 2, 2. Oh no. Oh no. 2, 2. Set these. I'm certain that this is wrong, and there's a better way to do this, but it's okay. Okay, I think one more, actually, because the 4-way doesn't need one. It's only one face. We're there. We've done it, almost. Okay. Rotate this. This goes in the left corner. This goes in the top right corner. This goes in the bottom right corner. This goes in the bottom left corner. Thank God it's over. It's over. Hey, and we've got hallways. Sweet. So now I have this scene. I think I have to re-export my mesh library. Now when I look at my map. Hey, that's something. That resembles a hallway. If I hit play, does it look like... Looks like shit. There's seams everywhere. But it's enough that I can start moving around. And I can clean this up later. In fact, that's probably what I'll do, because that was incredibly boring. Okay. So next, now that we have something that we can see, we can start implementing movement of the camera. So I think probably what I want to do is I have this like map representation in my maze scene. If I look at this guy, first thing we do is we generate a map. And I don't really like what's in the map right now, but here, where do I see it? So here we have generate map. And if I set like a breakpoint here and hit play, I guess I need to go one farther. If we look at the map, where is it? This is a useless view. I print it. Let's just look at what I print. So let's start. Each point in the map just has like a 4-bit integer representing which parts of the wall are open. This was hell. I don't like this. Obviously, this should be like abstracted behind some form of like class that wraps the 4-bit number, but I didn't know how to use classes in Godot yesterday, and I still don't. But I think it's worth learning a little bit, because what I'm doing here is when I'm like checking which walls are open, I'm just like taking the bit mask and where do I see get neighbor's position. I'm just like ORing them together to when I try to set which walls are open, and then when I check which which texture or which piece to use and how to rotate it, I have this like disgusting bit mask usage here. And so like while I'm thinking about this at all, if this was contained here, I would probably just leave it because it works already. But so I want to use this like integer representation of the map to do the movement of the camera, because I think the other option is using like Godot's, like I could like set up a path that goes through like the center of each of these tiles, and then try to use Godot's like path planning logic to try to like navigate through here without like colliding into any of the walls. But I think that like since I already just have what the map looks like in data, it makes sense to just use that. And then I can create like a conversion from like integer tile to point on grid, then use that to figure out where to move the camera around. So I think that's what I want to do here. So I think, let's see, what's the plan here? Plan is factor out Godot GD script class for map. And I have no idea how to do this, but we'll figure it out. Then we will use map class to convert map integer coordinates. So we'll call them tile coordinates, I guess, to 3D world coordinates. Then we can position the camera at arbitrary tiles, and then we'll set up movement of camera between tiles. And I think if we get all 4 of those things done, we'll... Oh, then I guess we have to implement like the navigation algorithm. But I think that like some of like the joy of watching these things is that the navigation algorithm is like shit. Just like absolute garbage. So probably what we're going to do is we'll just always turn left or something. I don't actually know what the Windows 95 one does. But I don't think it really matters. Either we'll just like go always turn left if we can, or we'll just randomly pick directions. I think randomly picking directions might actually be more annoying and therefore entertaining. Because if I like go down a dead end and then immediately just go back the way I came, even though there's like unexplored paths, that might be like frustrating to watch and fun. So yeah, let's start there. So let's start with exposing the map externally. So I guess I'll just make sure that I've committed everything, so that I have a nice little checkpoint for later. And I'll squash this down into something legible for future me later, but for now, we just checkpoint. I guess we just get moving. So I think what I read yesterday is that GD script classes are just files, and like static variable, like variables that are just sitting in the script are member variables. And I think that there was a way to like export functions. Inner class. Oh, this is what I was missing yesterday. This exists. Whoa, okay, that's way nicer. GD script inner class. That's like an actual an actual coding convention I can use. Where are like real docs? I don't want to just like browse form posts. GD script documentation. GD script reference. Can I just like inner class? Search that in here. Why? Why is this so hard to find? Class. Class. What about like keywords? Here we go. Class. Define a class, but it doesn't say anything. All right. Well, we'll try just like sticking a class and just start typing and see what the compiler yells at us for. But I will admit I don't like it. So we'll call this class map. Var. We will make this our array. So we'll call this like grid, I guess. And do they have like constructors? They must have constructors. GD script constructor. Can a class have a constructor? Override underscore init. There we go. So I guess if I just like put func init here, and let's say like item, let's just like print the item and see if this does what I think it will do. So when my script starts, let's just call, what did I call it? Map. And we'll take test. And we'll say var test map is the new class. Map is not a function. Go say new. Condition object's not true. Oh, this looks like something. What happens if I hit restart? Okay, that prints it. Oh, I don't like this magic. How do I know what this is doing? GD script new. Where? Oh, this is so okay. Okay, we'll just have to accept that that's some GD script stuff. Probably this gets mapped. We know that it gets mapped to the init. It might do some other stuff in between. Who knows? But that's fine. So now we can start trying to move some of the code that we were using before into here. So we can say, do I have to do self.grid, do you think? Let's find out. Grid is generate fully closed map. And it doesn't like that because maybe because this function was declared later. Maybe because this is part of the, oh, this is probably like a member function of maze. So can I do like super? Man. GD script call outer class function. Call function from another class. Or are there like free functions? That's really what I want. GD script free function. Blah, blah, blah. No. Jesus. Alright. What a language, man. What a language. So this is just like full OO. Alright. Well, I guess that kind of... That does make me feel like I just want to split out a file, because then I can like, at least pretend they're free functions. Let's do that. So I guess I just make a new script, and I call this like map data. Sure. And then Does this have to extend a node? Can I make it extend object? I think I read somewhere that objects are like lightweight nodes. And I think I say class name, we'll just call this map like this. And we don't have nodes entering the trees anywhere, so we don't need this, but we do need init. And we'll do the same test where we print out what we pass in just to make sure that we like understand how this works correctly. And now in this like maze class, we have to like import this somehow. So gd script import class. How do I include a script into another script? Is that really it? Here is instance name of a character class, blah, blah, blah. Blah, blah, blah. This isn't what I want. Like, is this? No, he's saying that's wrong. How do I create and import a class in GDScript? This looks like what I want. Sure, so I make my class, and then I can just use it, it sounds like they're saying. Like, I don't need to import. So here, if I just say, what did I call it in here? Map data, I called it map. So maybe this should just work. What happens if I play this? Yeah, okay. And let's just make sure that this goes where I think it does. Okay. So all classes are just in the global namespace. Cool. I don't get it. I don't really get this language. It feels like it's really, really forcing the like Java, all of everything is an object, which most people seem to not like anymore. Myself very much included. But whatever. We'll make it work. Okay, so I guess what we'll do is we'll start by just like copy pasting functions. I guess we can probably just copy paste like everything. And then we'll slowly replace functionality in the main script with this version of it. So we don't need this. Do we want to embed the maze size here? Probably not. We'll take that in as a parameter, I guess. Okay, so this ready function doesn't exist anymore. And I guess now we just start punching stuff in. So we don't need this mesh ID lookup. That's not related to the data of the map. That's related to, how do you say it? The like maze terrain class, I guess we'll call it. This is now a parameter. Get neighbors for position. This is still very much real, so I guess we will... Oh, I guess we don't need to pass this in as a parameter. We can actually say var maze size, and this will be set in the constructor. So we can then use this as a member parameter everywhere. Sure. And I guess in the same way, we don't need to like pass in map here, because it's just in the, ugh, it just feels like so much global state. I hate it. So we call this grid, I guess. And so here we can just call this grid everywhere. Grid here. What doesn't it like here? Expected indented block after 4. Sure. I just accidentally deleted it, I guess. Identifier maze size. Not found. Okay. Well, that's now a member variable instead of a constant. Or I guess a member... I don't know. However we want to say it. This now doesn't need this parameter. What doesn't it like about this? Get... sure. This is part of the outer class. Sure. Okay. So now I think all of these functions look like they work. And now we can just pass in the size. I don't know how to make it so that, like, am I gonna name collide if I call this map size again? Almost certainly, right? If I take, this seems insane. Well, but let's just see. So if I take in maze size, I say maze size equals maze size. Almost certainly this doesn't do what I want, right? That would be insane. This is obviously not the way. But we'll see. So if I say print test map dot maze size, what do I see? Null. Okay, well that's good. So I guess we just do like the underscore trick here where we set parameter names this way. Yep, okay, so now our maze size is there. And now we can do, now we can start implementing like accessors to this. So, let's see. I guess first we want to say, we want to wait to extract the neighbors for position. Get neighbors for position. Get open neighbors, get position accessible neighbors. Accessible neighbors, that's what we'll call it. So we want to say these are the places where the walls are open. So we'll call this accessible neighbors for position. And we take in a position. That's a vector 2. Can I like type print say that this has to be vector 2? Hopefully. Does this? Yeah, okay. It likes that. I like that. That's better than just like blindly hoping. I think here I was reading yesterday that you can set enum values, so I think I can just hard code these in like this into the enum. So I think I had this like this 0b001 0b 01010 and right was like this. Now I don't need this direction to bit mask function because the direction just is the bit mask, which means I can just delete these, okay? And that means that I can just iterate over the values of the enum and check if they're in the value position. So I can say map at the position that they pass in. I guess I'll return it as like an array of enums. Do I just expose the masking and let them do it themselves? Maybe that makes more sense. So I can say func neighbor mask at position like this, and this just returns map yx, right? And then I can say is right open for the mask, and return say check that right and mask. Is this what I want? Is this how I want to use this? So that means that from the maze class, I would have to do these mappings, these nasty mappings. I would replace these bit masks with like is right open, and it only right is open. which I don't like. I don't like that. Let's just expose the bit masks, and we'll just expose them as names, and then people can use them as they like. That seems easier. Which means that this is really all I need. And then we'll just have to be very, very careful converting these. But I think that I could just here say map dot direction dot right, map dot direction dot down. Yeah. This looks like it would work. Let's just close and open the game again to see if the walls are still rendering correctly. Looks like no. Invalid get index 0 on base nil. So this is maze GD 151. 151. And you're telling me that if I undo these, that error goes away? If so, that's extremely annoying. What am I missing? Because these should be equivalent, right? If I look in mapdata.gd up. Oh, did I might have flipped these. Let's check again. So this is left. So let's just, here, everything should work. Yeah. This, if I now replace this. This should also work. Yes. Looks like there's no crashes. How come? Oh, I forgot to reset these as transparent, which means that I can see through them. Or I can't see through them, which I really wanted. So that I can look at it from the top. So I guess we just have to go through each of these and turn on backface culling, re-export the mesh. Then in here, we need to recreate the mesh library. So we need to export as mesh library. And now when I go back to the game, I can see through, which is fantastic. And it looks like this is still consistent. Fun. So now I slowly start replacing these again. It does not like that. Which one of these did it not like? Interesting. Did I punch this in wrong? Right? Oh, I did. That's really fun. I love easy to mess up code. Which I guess is why I'm doing this at all. Is because this was really, really brittle. So hiding it behind some like nice function names and enums makes things a lot better. Okay. Oops. Can't find member direction, because I typoed it. Okay. Play. Cool. I have to be careful to go through these slowly, because if I get them wrong, it's like a massive pain to debug. So I think that now, if I do this, and can I like new line here? Hopefully, this still looks reasonable. Noise. We're getting close. getting close. I just have to slowly go through and fix all these bit masks. So this is right and down. So turn this to right. This is up and right. So change this to up. And this is up and left. Fingers crossed that this doesn't break anything. Yep, that looks good. Yep, that's still definitely consistent. 666. Time to punch in some more numbers. This is up and down. Here, down. And this is left and right. And let's put some new lines in here so that I'm not running off the edge of my screen. And I guess new lines here for consistency. Close, open, it's run again, check in 3D. All the walls look consistent, great. Great, great, great. We're getting close, getting close. So this is everything but down. Map, direction, up. Like this. This is everything but left, I think. Let's double check. Yep, that looks fine. And then this is everything but up. So this needs to replace up with left here. And this is everything but right. Let's replace right with up. And this is everything. And here we go. Map dot direction dot right. Okay. So this is still ugly as all hell. But at least I'm not working with the bitmaps directly. And so now I think that I can delete all of these functions. Like this. And just use the generated map class. So we'll use this var map. And now here, I guess these assertions need to move into the actual constructor here. And so we just replace map with grid on all these. These need to replace with maze size because they are no longer constants. They are an input to the class. Probably actually, can I rename? Do they have like batch rename here? This should probably be a private member. Nope. All right. I guess I'll just have to scroll through and see all the places where it broke. Grid needs to replace with underscore grid, needs to replace with underscore grid, and here. Okay. Right, so now instead of just accessing map directly, we say map dot neighbor mask at position vector 2i zx, like this. And we could say that this is the mask. And we pass in the mask like this now. and it breaks. What does it not like? The assertions are failing? That's cool because I never actually called generate maps. That makes sense. Generate map. And so grid equals this, I guess, like this. Refresh. Got a little farther. Because he needs my RNG passed in, which came from this. And we'll pass in a seed here. And we'll pass in the seed here. This isn't even like a real procedural generated map, so I don't know why I'm bothering, but it is what it is. Here we go. So this goes here now. Still unhappy. That is not good. I was kind of hoping that this would be the same. Oi, 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 oi. Oi, oi, oi. This is like a massive, like a perfect copy paste. So I don't know why this isn't working. Grid is nil. Why is grid nil? I said it here. Oh. I have to initialize this with an empty map. Empty. Here we go. Generate fully closed map. Oops. And then I guess this actually takes it in. This is like bad code. This is awful and confusing, but we'll see if it works and when we'll loop back to fix it later. Invalid index 1 on array. That's because this is wrong. I know that I fucked up the copy paste in there. God damn it. Why, man? Oh, this is our dot push back XR. How did I manage to screw this up so bad? How did I manage? Okay, so now what's happening? We're just frozen. How do I stop it? Pause. Oh my gosh, this is so frustrating. Where am I looping that I shouldn't be? Something's not working. So this is supposed to be walking my position stack. So what is my position stack? Null. That's not good. That's really bad. Why is that null? What the heck? That's strange. Because it's clearly... Like, I just wrote to it. I position stack, push back. Oh, something's broken. Print, position, stack. Like, what's it doing? It doesn't just be going forever. Which means that... How did I fuck this up so bad? Oh... Yeah, I don't understand. I don't understand. So if I breakpoint here, what does my map look like? It's an array. of array of zeros. Right. And if I continue to the next breakpoint, my map is an array of values. No, that's neighbors. Map is an array. It's still got zeros in here. Sure. Everything seems populated. I hate that just like copy pasting this out into its like own class caused such major problems. What's unseen neighbors look like here? Unseen neighbors. Okay. So is it this? Like remove visited neighbors. This looks right. Let's breakpoint here and see what's going on. So my input is position 6-2. Can I like just start typing stuff into the debugger? I want to just print stuff manually. Looks like maybe no. Looks like no. I suspect that this filtering isn't working right, which is annoying. That looks sane. Oh, man. Bugs, man. Let's just checkpoint because I'm going to start just like tearing this up. Let's breakpoint here, continue, and we'll just start stepping over stuff and seeing what happens. Okay, so neighbor position is 5-1. And I guess let's just print grid neighbor position. .y neighbor position.x. Play. We're here. Where is my console? Here. Oh, that's fucking broken. Oh no, that's not. 0. Okay, that's what I would expect to see. Which means that this goes in. Okay, let's pause this for a bit. And play. And then now this should definitely be done by now. And the fact that it's not is a bug. So here, this is my neighbor is 0. Oh, because my grid is just full of zeros. Because I'm not working with the grid directly in this member function. Oh, that's so stupid. In fact, I shouldn't need to. So, oh, it's because of all this like copy pasting from map to grid. This shouldn't exist, right? Okay, yeah, we figured it out. That's annoying. So it's because I like map used to be a local variable in this script, and now it needs to be the member variable of the class. That's so stupid. So this actually doesn't even need to return because he's just working on grid directly. Oh my gosh. All right. What isn't it like now? We made it farther. This is not a printable thing. There we go. Okay. Okay. And we close this and open it again. And it looks busted again. Specifically, I expect to see walls like on the outside, and I expect to see wall consistency, which I'm not. There's like another, I don't know how I managed to reintroduce this rotation bug. Oh, that's annoying. That is annoying. Oh, it's because I found it. So here I passed in ZX as my vector, but it's XZ. That's so stupid. There we go. We're in. So we now have our map class that correctly abstracts these like stupid bit masks. We fucked up like 40 times along the way, which kind of gives confirmation that splitting that stuff out was going to be helpful. It doesn't actually look that much different, so I just took on a bunch of pain for no goddamn reason, maybe. But it's okay. So, save. We will git add this and commit it as a checkpoint again, because I know I'm going to make another mistake. Let's make sure that our prints are gone, because I don't want this just cluttering that up. Okay. And now I have something to start working with the... What is this called? I can now start like working with the camera controller. So I guess conversion from tile coordinates to world coordinates probably belongs in this like class that instantiates the tiles. That seems to make sense. So here I'll say like grid to world coordinate. And I'll take in a vector 2i. And I'll convert this to what? What does this return? This returns a, I guess just like a 3D transform. I guess I could also just represent it as like vector 3. That seems pretty reasonable. That seems reasonable because there's no rotation attached to these. I guess there is. There is a rotation. Because if my map was rotated 90 degrees, this mapping... Oh, there would still only be a position at the center of the tile. Yeah, okay. So... What do I do here? There's probably like grid map get cell position. There's got to be some way to do this from here. Cell center. No. None of these look like what I want, right? So there's like get cell item. Ooh, get cell item basis. That sounds right. Let's just call that. Get cell item basis chord. And then this vector 2 needs to be converted into a vector 3. Like this. Chord.x, 0, chord.y. I can always return this. And okay, so from my, I think that's probably all I need. Grid to world transform. I gotta be careful here because if my grid map is not positioned at 0, 0, 0, I suspect that this won't, this is probably like with relative to the grid. So I probably, is there like a way to just like get a basis of me? Like get let's see, like godot get transform blah 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 blah, say blah blah blah. Oh, so I just probably have like a transform. Yeah, and I'll probably just do this. I'm assuming it's right to left multiplication. Introducing transforms. Rotate the transform on the x-axis by 1.0 radians. Yeah. Yeah, so you take this matrix and you multiply. Yeah, right to left. Solid. Okay. So now let's try. How can we confirm that this works? We should, in our game script, set the camera. I was going to say set the camera at a specific grid cell location. But actually what I can do is I can just instantiate like a ball there or something so that I can look at it from the editor. So here I can just say, let's do it in the game script. Do I have a game script right now? No. New script. We'll call it game. And from maze, we have, do I have to export this function or something? Export. No, I was calling those other functions. Let's just try copy pasting that function name out and see if that does what I need to do. So we'll just say it like 0, 0. And I guess we just print this. Sure. Expected closing bracket. Okay. And let's run this from the editor. And so now I think if I just reopen this, I do in fact get 1, 1, 1. And if I move this guy around, it should now not say that. Now it says x -1, y 1, z 1. Was that really a perfect translation? No. In fact, it moved along z. Am I crazy? Maybe the basis was already in world coordinates? Maybe. What's happened? What is this by itself? I kind of assumed it wasn't, but nope, this is doing the same thing. This is doing the same thing. Get cell item basis. I guess let's print the maze transform just to make sure that I understand what I'm looking at. Print maze transform. Yep, so he's moved over by 2. What is basis then? Odd. Odd, odd, odd. Oh, so that's the matrix of the object to the mesh, and then I need its position in the world, which is not the basis. Okay. Okay, sure. So that means that in my maze script, I just need to multiply this by transform, like this. And now when I hit play, it doesn't like that because probably it's a 3 by 3 matrix instead or something. transform 3D and basis. So how do I convert a basis to a transform 3D? How do I get out of this? No, that's not what I wanted. Okay. Get cell item basis returns basis is a 3x3 matrix for rotation scale. Oh, so that's actually not what I want at all. I wasn't paying attention. I should have read docs. Classic. So is there like get cell item transform? Like anything that gives me a vector returns the map coordinates of the cell containing the given local position. That's the opposite I want. Map to local. Returns the position of a grid cell in the grid map's local. Yeah. This is actually what I want. Okay. So now... let's look at the game script again. What was I typing here? Hello, game. So here, I want grid to world transform is giving me 1, 1, 1 again, which is not what I expected. I expect this to be like 1, 1, 2, 9, 8. What is this actually? Origin. This is O for origin, probably. Okay. Okay, we're getting close. So what happens if I print just like mapped local? 1, 1, 1. So how come when I map... Oh, because there's a vector 3 that comes out, and I need it to be a vector 4. Probably. Let's look at the transform. Because probably the transform is a 4x3 vector. Or, sorry, array. Matrix. That's the word I'm looking for. And if I multiply position by that transform, I'm surprised it's working at all. So let's actually look at the transform class. Transform. No, transform 3D. Transform 3D. Here we go. So if I multiply this with a vector 3, what does this do? Am I crazy? Transform 3D is a 3x4 matrix. So why does multiplying by a vector 3 even work? Right? Like, what does this even do? I'm missing something. Godot, apply transform to vector 3. Using 3D transforms. We're back at the simple doc. Okay. Blah, blah, blah. Yep. Introducing transforms. Okay, so we have vector. Yep. But how do I... So if I multiply this, I'm not getting the translation, I assume. I mean, I should be. Let's try actually... Let's just work directly. Let's screw all of this, and we'll say... We know that this transform is translated, and let's multiply this by vector 3, like 0, 0, 0, right? Like this should be 2.98. It should be. And it is. Okay, so that actually does do what I think. So then why is grid to world transform not doing that? So if I go to maze, if I multiply this by my own transform, that should give me 1, 1, 3-ish. What the fuck is it doing? What am I missing? Maze, grid to world transform. Does Is transform not what I think it is? No, because it's this. Right? So how come when I do this... Oh, because I'm looking... it's so stupid. It's so stupid. Yeah, okay. I was looking at the transform of grid map relative to maze, but I wanted the transform of maze. Oy, 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 oy. So these actually aren't like world coordinates. So this should be maze transform. Because this is not its absolute coordinates, clearly. Clearly. Right. No, because this isn't relative to the maze. This is relative to the parent. So grid to, we'll just say grid transform. We'll just leave it ambiguous because I don't know how to name this well. Perfect. Grid transform. We'll copy paste this. We'll use it in the game script. And all is right with the world. So this is now very far offset. And now probably if I rotate the map even, I probably still get something I like. So let's just like, well, and so now I should get a big Y value instead of a big Z value. I get a big both. Oh, because 1.0. Yeah, okay. Sure. So let's reset these. Okay. And now let's position the camera at 0, 0. And so we should see it here. So if I say camera 3D dot transform is this. It doesn't like that. What doesn't it like? What does it not? Too many brackets? Sure. Okay. Unable to set index transform on base camera 3D with type vector 3. Oh, because I need to set my direction. Sure. Because this is a... So, can I just say position or something? Like, do they have... Position on base transform 3D with type vector 3. Okay, let's look at the docs again. Or, I think it's in here. Search help. Transform 3D. So can I just set the position by itself? Looking at... Huh. I really thought there would be some way... Oh, origin, here. Here we go. I can set the origin, and that would do what I want. So, origin. And if I close and open game... Where the hell is my camera? Okay. Yeah. So camera's at 0, 0. Now what if I want to put it at like 15, 0? I should see it here, I guess. Yeah. Okay, so game. Oi. Where are we looking? Here. So if I put this like 15, 0. And then close and open this. I expect to see it here, which I do. Nice. Okay. And now we can just start making it wander around. So in this script, I think it's physics processes where you usually would handle character movement, and we'll call the camera a character. We want to keep our camera position in map coordinates. So we'll say map chord or grid chord. And we'll start this at 0, 0. Um, we'll set our desired coordinate. Desired grid coord. Is that what we want? So when what are we gonna do? We're gonna be like at a location, and when we're gonna pick a direction. So let's start there. So we'll say we're at grid coord, and we are going to move towards an open position. So we need to say maze map, and inside here we have neighbor mask at position, I think. I don't know why this isn't auto-completing. That's really bothering me, but we'll live. And we pass in our grid coord here. Okay. Now we like set our desired position. So, oh, I see. So if our current position is not equal to our desired position, we are currently moving towards desired spot. Okay? Easy. Otherwise, we need to set a desired spot. So actually, probably we're always going to want to be moving. So we actually want this condition to be set the desired position. So here we find the available slots, avail neighbors, right? Then we say, well, what are those available neighbors? So we have to convert those into like grid coordinates, which I believe is a function that we already have somewhere. So let's call this neighbors to positions, and neighbors is an array. We have direction to vector already. So we can just say that we can return pause plus we have like a return vector, or we should call this an array in this context. And for neighbor in neighbors, we want to insert the position plus direction to vector of the neighbor. And then return ret. Expected loop variable after for. Do I need to like, is it like this? Yeah. Okay. And so now from the grid, the game controller, we can call maze.map.neighbors. No, this is wrong. This is what I implemented was wrong. This doesn't take an array. Where'd it go? Here. This takes on neighbor mask. So I say if neighbor, do I already have, this must already exist. I must already have a function to check which options are open. I guess I don't. Neighbors to positions. So if neighbor mask and direction up, ret.push. And I think, are these supposed to be in parentheses? I don't know. We push back pause plus direction to vector direction up. And we do this for direction in direction up, direction down, direction right, direction left. All right. So this gets indented. We call this direction. And we call this direction. Okay. So now we have our neighbor, we'll call this neighbor mask to positions. Yep. That's good. So neighbor mask. So available neighbor is neighbor mask of positions, and then say we then reassign this to neighbor positions. I think, would I call it neighbor positions from mask? Why is this so hard? Let me autocomplete. Whatever available neighbors. Okay. And so then, now that we have this, we just pick one. So chosen neighbor is random number generator, and there's a rand_i range, I think. Searching randy range, random number generated. Do I have to make a new RNG to use this? Godot random numbers. Let's see it. Oops. Close. Random number generation. There must be like a function that I can call instead of like. Oh, it is just random.rand_i range. Okay, I think there's probably just a global function for it, it looks like. So I just do this. Randy range from 0 to available neighbors.size -1. And we say this. Like this. And this is in grid coordinates. Chosen neighbor grid. So we can actually just set this here. Desired grid coord is this. We picked one. So now we know that the desired grid coordinate is different than our current grid coordinate. So we need to start moving the camera in that direction. So we'll start with giving him a speed, and we'll just call it like 1 for now. And our camera's transform origin should be, so let's find the position that we want. So our desired grid coordinate is this. This is desired maze position. Desired position, we'll just call it. And this is, we get the grid transform of our desired coordinate. What the heck? Our current position is the same thing, but with our current grid coord, right? And then we just say our origin is desired pause minus current pause to get the direction. We normalize this to 1.0. And then we multiply this by speed, I think. And I think if I hit play there, our camera will just start, like, moving around. I think. Let's see. Oh, it didn't like that. Failed to get index on base node 3D. Index map. Amazed. Why? That explains why it didn't like this. Do I have to, like, export? So I have... Oh, because this is not a member variable. So here, I just do this. And... You don't like having mapsies? Invalid call, expected 2 arguments. What doesn't it like? What doesn't it like? So here I have position and neighbor mask. Oops. Right, so my position is the grid chord. Hey, that's good. That did something. Let's speed. We need to slow this down a lot. Physics process. We also need to do this times delta, right? We just completely forgot that. And so let's see. Okay. Okay. He's moving. Is he gonna go forward? He's just always going that way. Forever, huh? And he's just going straight through the wall. Alright. Okay, so what are we missing here? Dude, yeah, he was moving. Barry Allen, good reference. Yeah, that was nasty. Are you still watching? Damn, dude. You've put up with a lot of me just complaining at my screen. But 30%. Alright, I'll take it. Dude, he was moving. Okay, so why... Is this normalized call not doing what I think? Let's just see. Print this. Yeah, that's very much just never changing. Oh, it's because I never update my current position. Right, so when I get there, I have to set my desired grid chord to grid chord. Easy. So how do I say that? If desired... Oh, it's because my current pause isn't like the grid coordinate. That's stupid. It's just my position. Transform camera 3D transform.origin. No. I thought that would do it. That should just like ping back and forth between like around a tile. So I'm still doing something wrong. Let's print desired pause, current pause. Oh, because I just didn't instantiate where I put the camera is just wrong. That's good. Okay, so let's put this in here. And so here I should see me stop here. Yeah, there we go. Rapidly vibrating. But that means that it's moving in the right direction. So now I can just... Uh-oh, stop it. Why are you spamming the console? That's really bad. Okay. Okay, so that means that the movement is working, and now all I need to do is update my grid coordinate if I'm there. So if I am close to the desired position. There's probably some way to just say like, come on, hit me with vector 3, like length, probably, is less than some small amount. We set the current position, or the grid chord to desired grid chord. Okay. I probably want to use like length 2 or something, but that's fine for now. Okay. Okay. Here we go. That's sick. He's moving around. This is stupid. He should never go exactly where he just was. Unless there's no other options. But that's really good for now. Okay, so let's just do the only other thing and have him look in the direction that he wants to walk. So can I just point at? There's gotta be godot point at. Yeah, just look at. Okay. Can I do that? So if I just say camera 3D dot look transform, transform 3D. So, right, this is too simple. So can I look at like camera 3D? Does he have like a look at? Because that would be easier than doing the math myself. Maybe not. Godot camera look at. Oh, do I just actually have to do the math? Oh no. They're saying that this exists. How come I don't see this in the docs here? Is it because he like inherits from node 3D and node 3D is the one who has look at? Look. Yep, that's cool. I wish the docs there showed all inherited members, but that's fine. It's fine. We'll make it work. Look at desired pause, and up is just up on Y, so I think. All right. Okay, so I guess we need some rotation time. There's gotta... Oh, that's... It hurts. Okay. So, I guess we should say, if we're not looking towards the desired position... not looking towards desired pause. And so that's just... I need to actually get the vector into like, what, dot product, where I'm looking with the output and see if that's really low. And that means that I need to get my current direction that I'm looking from the camera, which means that I need to look up some docs. So, camera 3D, does it have like where I'm pointing? Maybe on the node it will have which way I'm looking. Rotation. Is this, what is this? Rotation part of the local transformation in radians specified in terms of Euler angles. Gross! I want, like, just which way I'm facing. Can I say that? Camera 3D Godot vector pointing direction. There's probably a better way to search this, but here we go. Get global transform dot basis dot c. Oh. Okay, that's useful. That is useful. Works for me. So if our current, oh gosh, what was it? It was get global transform if transform base the camera transform the rotation part of that and the z value of that rotation, which is forward, dot okay, so we'll call this var movement direction is this. So if our dot of this is greater than something, we will, if it's less than that, or if it's greater than that, if it's greater than that, we do a slow rotation. Rotate camera. Pass. Else, we do this. And this is now already factored out to this movement direction. That's spelt wrong. So it's supposed to be movement direction like this. And I guess we can like rotate towards. Which means what? We have, I guess that's like some sort of like, what do they call it? Slurping? SLERP rotation. Slurping is shorthand for spherical linear interpolation. Right, so for the purpose of animating 3D version, this is exactly what I want. So that means Godot must have this. Godot slurp. I'm sure it has it. Let's not use the Q&A. Godot animate rotation. Slurp. Is there a function for it? No. So rotation degrees. Oh. I want to know which direction I should rotate though. Which is this what cross products are for? I always forget. So if I have A and B, cross product is the vector to rotate around. Perfect. Perfect. So var rotation direction is okay, we'll call this var look direction is this. Rotation direction is, let's just say, that's a rotation axis is the look direction cross product with the movement direction, which was misspelled there. And so say if the look direction dot movement direction is large, we need to do some movement. Call this rotation step. So if we're above the rotation step, then we need to move by the rotation step. I think that's right. Find out. I think that actually might be wrong. Because I think A dot B is cosine. Let's see. Dot product. Blah, blah, blah. Where do I see is AB cos theta, I think, right? So with two normalized vectors, it just gives me the cosine. Oh, come on, where is it? I'm pretty sure it's just, yeah, AB cos theta. But I actually just want the angle between them. So let's just ask Godot. Godot, angle between vectors. Do they just have a function for it, or do I have to do some math? Angle to point. Alright. Works for me. So, angle to look at is look, my look direction dot angle to point movement direction. And they're saying that's like a function that exists. Rotation step, and we'll just call this like, I don't know, 0.1, doesn't matter. So if angle to look at is greater than rotation step, we need to move 15 degrees in that direction. So we say camera 3D rotate. I think I can just multiply its current transform. We take the current transform and we rotate it by a basis that we construct out of the axis and angle, I guess. So axis, angle, right? So here our axis is the rotation axis. And the angle is this rotation step. And do I start to see, okay, good. That's no function angle to point, right, because this is a vector. So, does vector 3 just have like angle functions on this? Cross, bounce, blah, 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 lerp, project, reflect, rotated, round, signed, angle 2. Yeah, okay. Let's use that. That sounds like what we want. Signed, angle 2, and this should be around the y-axis, actually. Because I'm only ever rotating horizontally. And so that means I don't need this. I can just say const rotation axis is this. Y-axis up. Maybe it should be y-axis down, but it doesn't really matter. Because this is going to be signed. And here I can just put like this. Boom, 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 boom. Restart. Okay. I need to convert this basis to a 4x4 matrix, so I'm assuming that they just have like a 2 4x4 in here. Or maybe like a transform 3D can be constructed from a basis. Yep. Okay, we'll just do this. So we'll construct our transform 3D from this, and origin vector 3 0 0 0. So we are not moving, we are only rotating, and we want to multiply that by the current transform. This should give us a new transform that's like us rotated. Oh Jesus, what just happened? Fuck, man. Okay, so I actually think that I probably just have these reversed. This happens to me a lot. So this needs to go like this because I want to rotate, then do the rest of the transform, probably. Okay. Okay. And let's just see what this rotation angle will get, or this guy is. Rotation step. So we're getting close. He's spinning. So sometimes he is false, but then it just like completely resets. And that's because I set the transform. No, that should be fine. Oh, it's because the look at. Here, maybe. Oops. Okay, so it's just always false. False, 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 false. So what is it? Print angle to look at. Is it possible that this condition is... No. It's... Oh, because it's signed. So I think I just need this to be abs. Like this. So it is... I am seeing it be false and true. True when I'm looking in the right direction, false when I'm looking away. But then, like, why am I still moving? Like, I shouldn't be seeing myself move forward in that case, right? Like, let's just comment out all of this else block, and I should see myself never moving. Hello? Yeah, see, not moving. So... Oh, because I didn't put abs here. I'm an idiot. There we go. Maybe... No, because I'm still seeing it. Is it because my, like, if condition is, like, in brackets or something stupid, and that's, like, converting it into something I don't want it to be? Okay. There we go. That's looking really good. I mean, I'm looking the wrong way. But that's looking really good. So all I need to do here is invert this. I don't really understand why I have to invert that. No. Look direction. Movement direction. Okay. Well, we'll just do this and see if... Okay. That's not bad at all. So let's just reduce the rotation step a little bit. Keep him moving backwards forever. Yeah, that's not an awful idea. Okay. I mean, other than the fact that he's just running back and forth forever, let's see if he ever makes it out of this hallway. Yeah, okay. That's not bad. And if I, like, put this in the corner of my stream like this... Okay. That's something. I can just do this. Okay, I definitely need to prevent him from backtracking that much. That's really fucking annoying. No, that's, yeah, it's almost certainly not, right? It's kind of funny, though, to let him do, like, maybe that's funnier. I can't really decide. I think almost certainly not. I think almost certainly I should not let him just do this. This is so fucking stupid. Because here, at like each turn, if there's like a 90 degree, there's like a 50% chance that he just turns around. This is this is me on the phone. Yeah. Yeah, me too, buddy. Okay, you know what? I think that's... Oh my god. Why did he just turn 270? Does he only ever turn left? Yeah, he does. He only ever turns left because I'm moving by rotation step, but I need to be moving by rotation step like yeah, no ambi-turn is here. Yeah, we could leave it in as a little like Zoolander reference, but I think probably here I just do rotation step like times the direction of this angle to look at. Is there like a way to get the sine out of a float in here? In C++ it's copy sign. Let's see if Godot has something similar. Add a copy sign XY method. Nope, okay. Well, we can still do this by saying times angle to look at normalized, I think? Is this a vector? No, this is a sine angle. Ugh, that's annoying. Copy sign, blah blah blah. Oh, there's just sine Y. I can just do that. Sine angle to look at. Okay, there, he turned right that time. There, he turned right. There, he turns all the way around. I guess we should probably like prioritize moving him forward as well. But okay, for now, this is enough. I've been streaming for 2 hours, which makes for too long of a video. So thanks for tuning in. This has been fun. And this is pretty satisfying. Lots of cleanup to do that I'll probably do off screen. I don't think it's fun to just watch me texture this wall better. But next stream will probably fix this like turning algorithm so that he doesn't just like full 180 all over the place, and maybe add like a goal, because it's kind of a bait to just leave it forever with like have him wandering these halls with no way out. Yeah, all right, cool, thanks, catch you later.